Welcome to Pure One, Chapter 14.7, where this lesson we are looking to natural logarithms. Yes, logarithms are like many humans. We have natural humans and non-natural humans, where you put a lot of makeups on. Anyway, so talk about natural logarithms. Just kidding, by the way. Please don't take any offense if you listen to this. Right, anyway, so by default, logarithm has base 10, we know that. But when a logarithm has base e, we mentioned what's the e? E is an exponential number with 2.718, invented by the very famous mathematician Euler. It is known as the natural logarithm, denoted as ln. Now, that's an L, not I. It's not in, okay? If any of your name has an IN in there, probably use that calculator, use that symbol in the calculator, type your name in the calculator. But that's an ln. Now, some people call this ln, like I do. Some people call it ln, which is not the right, not the right way of saying it. You can say ln. You might see people heard or learn, or some people just call it natural log. Okay, so there are different ways of people calling it. I call it ln. So the reverse of e to the power of x is ln, and the reverse of ln is e to the power of x. So you can think of it like the relationship between times and divide. Okay, it's not exactly the same, but one cancels out the other. Okay, so we have to understand how they cancel out. So for example, in here, y equals e to the power of ln x. So let's do a bit of investigation on how they cancel out. So now let's say we apply ln on both sides. So if we apply ln on both sides. Now, when you make notes in maths, it's probably best to write something like in here. If you don't understand how does this step one to go to step two, write a little notes next to it. Okay, what's happening in here? This happening. We apply ln to both sides. Oh, to both sides. Okay, so that's what That's these little words. Little notes help you understand what's going on in here, and that's what very important when it comes to revising maths, especially proofs. You need to understand what's going on every step because you don't want to remember the steps, but you want to remember what you're trying to do. Okay, what you're trying to achieve. So next, LMY. Next, on the left hand side with LMY. Now on the right hand side, if you remember about log laws, okay, the power law, where we can bring the power down, we can do the same for ln. So we're gonna bring the ln x down. So it'll be ln e to the power of 1. So what is that? What we're trying to do in here? We have applied the power law, where ln of a to the power of k equals to k ln a, right? Okay. So we'll be thinking, what about log? ln is just a different version of log. ln is also log. By the way, oh, damn, I forgot to mention this. So this one here, sorry, I forgot to mention this. So log e of, let's say, a is same as ln a. That's what it means. That's what it meant. Have I explained? Have I introduced? No, I've not introduced ln before. Sorry, it's the first lesson. So base e. So with base e, then with ln. So we can rewrite log e as ln. So all the log laws still apply to ln. All right. So so that's what we've done. We have take the power down. Okay, we have take the power down to ln x in the front. Okay. Next, what is ln e? Well, if you put in a calculator, ln e in here. Okay, so ln e is the same as log base e of e, which is just 1. Why? If you remember about the relationship between the base and the number in here, we talk about what's the power of the base gives rise to this whole number, this number in the bracket. E to the power of 1 is e. Therefore, log base e of e is 1. If you don't know what I'm saying, try putting a calculator, log base 10 of 10 or log base 5 of 5. We know that always equals to 1. So log base e of e, ln is same as log base e of e, which is 1. So the next step will become lny equal just ln x, because that cancels out to 1. So lny equals ln x, therefore y equals x. So what I try to prove in here, is that if y equals to e to the power of ln x, then the e and ln will cancel out, and then y will equal to x. So e will ln and if E and N cancel that way. Okay, that's what I'm trying to say. So we have a little example in here. We can give you a small example, e.g. in here. Okay, e.g. if you have y, sorry, not y equal. If you have e to the power of ln, let's say 3, that will give you 3. E to the power of ln, I'll just make it up, x squared, that will give you x squared. Okay, so just a small example in here, a few examples, just to help you get your head round with how e and ln cancel out. Okay, now next one, what about y equals ln ex? Or this one, okay, the first step we're going to write is we're going to change the log ln into log. So log base e of e to the power of x. Okay, and we know log base e to the power of x, we can use, now there are different ways you can say it, okay, you get different ways you can do this. You can apply the base law, okay, log a b equals c, a to the power of c equals b. So what I've done in here, I've applied the base law. So a to the power of c, sorry, base log ab equals c, that's the same as a to the power of c equals b. Okay. So e to the power of equal x, again, y equals x. Therefore, okay, therefore, good apply. Therefore, if y equals ln e to the power of x, then the ln e cancel out. That gives rise to y equals x. Well, what does that mean? E.g., okay, if you have ln e to the power of 5, then the ln and e will cancel that way, so it's 5. If you have ln e to the power of 2x, then you have just 2x. Okay, so rule of thumb. Rule of thumb, rule, English, rule of thumb. If you have e first, e as a base, then you cancel ln that way. If you have ln first, you must cancel ln and e that way. Okay, I'll show you a bit more example later. Okay, but this is how the algebra works between ln and e, which you'll use it very frequent. Right. So a summary. Oh, I'll give you a summary in here. So a summary, to get rid of e in the e to the power of x, we apply ln in the front. Okay. If we want to get rid of ln in the ln x, okay, let's say we want to make x a subject. If we want to get rid of ln, we can put it as power of e. So the graph of y equals ln x. So let's sketch a graph of y equals e to the power of x, which is everyone should be aware of by now. Okay, that's 1, and we know that y equals e to the power of x. Okay, so that's y equals e to the power of x. Now, we know ln and e are the inverse. So inverse means if we draw the line of y equals x, then the graph of y equals ln x will look like this. And this is graph y equals ln x. Okay. So a note in here. Y equals ln x is the inverse of y equals e to the power of x. Therefore, the graph of ln x is a reflection of e to the power of x in the line y equals x. So if the inverse, essentially you can reflect the line over y equals x. Okay, right, so that's the graph y equals ln x. Right, example, solve e to the power of x equals 5. To solve e, now we don't like e, so how do we get rid of e? So look at this one, how do we get rid of e? To get rid of e in e to the power of x, we apply ln in the front. So we apply ln on both sides. You can't just apply the one side, you have to apply both sides to be fair, okay? So ln, so apply ln on both sides. And ln and e cancel out, so x equals ln 5. Simple as. Now this is called exact value, so this exact value. So this will happen, for, again, quite frequent. Where they give you as exact value, it's like third form. You can't, if you put ln 5, you realize you get a really weird decimal number, which sometimes we don't need it. We just need the exact value, like third form. So solve ln x equals 3. So to get rid of ln, we put it as a power of e. So what do? We both sides. E and ln cancel out that way, so x equals e cubed. Again, this is called exact value. Okay, we don't need to put in calculator. Let's live like this, exact value, like pi. Next one. Example, solve e to the power of 2x plus 3 equals 7. Same thing. To get rid of e, we apply ln on both sides. So let's apply ln on both sides. Ln and e cancel out. So 2x plus 3 equals ln 7. Of course, I'm not going to write over my BF Maths logo. So, and then we subtract 3 on the right hand side to make x subject, to subtract 3 on right hand side. Now, this looks confusing because are we doing ln 7 minus 3 or ln of 7 minus 3? To avoid the confusion, we usually put a bracket around it. Or an even better way, okay? Or an even better way is we write it minus 3 plus ln 7. We usually leave the ln term at the last term in a train. Think of it like a train, like a different carriages. We leave the ln 7 usually at the end. So to avoid confusion. Okay, so what I'm going to do is then we divide by 2. So divide by 2, we can do minus 3 plus ln 7 over 2, or we can write as x equal to minus 3 over 2 plus a half ln 7. That's the usual way we write it down. Okay, so learn this way. We divide by 2, we split the numerator. And when we do ln 7 over 2, we don't write over 2, we write a half ln 7. As if the ln 7 usually leave it at the end, very end. Okay, example, this one, next one. Now think about what we can do first. I'll give you 5 seconds to think about what should we do first. What would you do first? Yes, I would minus one on both sides. If you think of anything else apart from minus one on both sides, you're wrong. I mean, you're not wrong. There are many, many ways to do maths in like to do maths, like how we eat nuggets. There's different ways we can eat nuggets, right? We can eat in one chunk, or we can eat. Some people eat the skin first and then the meat. Oh, that's crazy. So we'll do minus one first because that will make life a lot easier. So 2 ln x equals 5 minus 1 is 4. Then, then there are two ways. Okay, one is the simpler way is to divide by 2. So ln x equals 2. Then e on both sides because we want to get rid of ln, right? So e and ln cancel out, x equals e squared. Or, oops, or what we can do in here is we can bring the 2 in the power. I was going to show you different algebra in here because you want to open your eyes with different algebra that could be applied into ln. So what we've done in here, this is the power law. Remember, so ln a to the power of k equals k ln a. We're just reversing the process. So power law. So, and then e on both sides. So e of ln x squared equals e to the power 4. E and ln cancel. X squared equals e to the power 4. When you square root it, you have plus and minus. So you have positive e squared or negative e squared. Well, why is e to the power 4 squared is a square root is 2? Because if you think about square root means power of a half. Power of a half, 4 times a half is 2. But right, so how do we have two answers here, but we've only got one on the left-hand side? Well, if you remember, you can't log negative. So we have to reject that one, okay? You don't have to give a reason exam, but I'll just show you because you cannot ln negative numbers, okay? Or log, okay? So that's the only answer, okay? Right. If you're happy with this, try this on your own, have a go, and give your answer exact value. So pause the video, have a go of the question. When you're ready for the answer, you can press play. So these are the final answers. Okay, so part A, get rid of E with ln on both sides. So ln and E cancel out. So I'm just left with x equals ln 6. Okay. B, e to the power of minus x plus 3 equals 20. Again, to get rid of e, we get ln on both sides. So get rid of ln, ln on both sides. So give you ln and e cancel out. So ln 20. And then you minus 3 on both sides. When you minus 3, I put a minus 3 in the front first. Doesn't matter. And then multiply minus 1 across, you get x equals 3 minus ln 20. Actually, to improve this answer, we should improve this answer because 20 is like, if you think about third form, if you write root 20, we know root 20 could be written as 2 root 5, right? Put in the calculator. We know that sort of in our head, we know that could be sort of rationalized. Now, ln 20 is actually not different, not something too different. If you think about ln 20 being, ln 20 is it 2, hang on, 2 5 squared, hang on, it's not 5 squared, it's 2 4 times 5 is 20. Can we rationalize ln 20? I'm thinking, hang on. 2 squared times 5, right? So 2, actually, ignore me. Don't worry about that. 2, 4. Yeah, don't worry about that. Sorry, my bad. Yeah, no, my bad. Ignore me. Ignore me. Just waffling in here. Waffling. Brain's not working too well. Too much ln, too much e. Question C. Okay, if we're ln 80 minus x, if we want to get rid of ln, we put it on top of, put it as a power of e, then e and ln cancel out, becomes e to the power of a half, and then we got 8 minus x equals e to the power of half. Again, we didn't put a calculator because we want exact value. Exact value means if you put in a calculator, if you know any decimal, that's not exact. So leave it like it is, and then a minus on that side, make x subject, I get this answer. For question D, first I divide by 2, so give me 7 over 2. To get rid of ln, we put it on power of e on both sides. Remember, whatever you do left hand side, do the right hand side. And it gives you e to the power of 7 over 2. Just make x on the subject in that one, and then divide by 3. Okay? Right. More. E to the power of 2x plus 5 e to the power of x equals 14. Hopefully you recognize this is a disguised quadratic because the power is 2 to 1. If you look at the power, it's 2x and 1. So what can we do? In a disguised quadratic, okay, you let y be the middle term. Okay, be the middle term. So we let y equals, to e to the power of x. So e to the power of 2x becomes y squared plus 5y equals 14. Bring the 14 to the left hand side. Okay, do your, use a quadratic formula or calculator. You get y equals to minus 7 or 2. We're not interested in y, so put e to the power of x back in. We want to get rid of e, so what can we do? We get ln on both sides. We get ln on both sides. Now, what you realize is ln 7, you can't add negative 7, so there's no solution for that one. So, okay, ignore it. So, ln e to the power of x, so x equals to ln 2 is the only solution. So, not all quadratic has 2 solutions. This one only has 1. All right? Easy? Peasy. Your turn. Okay, here we go. Okay, pause video, have a go at the question. This is a disguised quadratic because if you look at the power, it's still 2 to 1, even if it's x over 2. Think about a half being the 1 and then x becomes a 2. So let y to be middle term. Pause the video, have a go at the question. Okay, when you're ready for the answer or you're struggling with it, you can press play. Here are the final answers for A and B. Okay, if you got right, well done, move on. But if you don't, I'm going to go through with you why. Okay, question A. So, as I've said, this is the middle term, so we'll let y equals to e to the power of x over 2. So we have y squared minus 3y plus 2 equals 0. Now, if you're struggling with why is it y squared in here? Because if e to the power of x over 2 is y, okay, so e to the power of x is the same as e to the power of x over 2 squared. So that's the same as y squared. Okay. So y squared minus 3y plus 2, put in a calculator, you should get y equals to 1 or y equals to 2. Oh, actually, I forgot that's x equals 0 in here as well. So e to the power of x equals 1, so e to the power of, or e to the power of x equals 2. Something to the power is 1, so x is always 0. Okay, I mean, something, sorry, e to the power of something is 1, so the something must be 0. E to the power of x equals 2. You can ln on both sides, that gives you ln 2. Okay, half ln 2. E to the power of, oh, hang on a minute. I made a mistake. Hang on, I made a mistake. It's x over 2, right? Sorry, it's e to the power of x over 2 equals 1 or e to the power of x over 2 equals 2. My bad. So if you ln on both sides, you get x over 2 equals 0. So, oh, ln1, sorry. ln1, 0. So x equals to 0. When you calculate, you'll see. This one, x over 2 equals ln 2. So x equals to 2 ln 2. Actually, I made a mistake in here. It should be 2 ln 2. Okay. Part B. We have negative power. I actually did something similar in the last video or the 2 videos ago on the challenge question at the end where I do the negative power as well. So the first thing we should do is put it as a fraction. Then we multiply every term by e to the power of x. That's how you solve equation with negative power. Put it as a fraction, okay? And then here you can let y to be e to the power of x. So it becomes y squared minus 5y plus 4 equals 0. And then you can put it in the calculator. You should get, if I'm not mistaken, minus 3 plus 2. Yep, the other one is, yep. So you should get e to the power of x equals to 1 or e to the power of x equals to 4. Okay, right. So you get ln on both sides, ln1 or x equals to ln4. So ln1 is 0. Now, x equals ln4. Ln4, 4 is a square number. So now this is perfectly fine, but sometimes they'll also ask you to put it in ln2 format or something. So we can rewrite x equals ln2 squared, which is 2 ln2 as well. So both answers actually give the same answer. But you'll need to know how to change ln4 to ln2. Okay, right. And one more exam practice or challenge question. Okay, pause video. I'll give you a hint on both how to start. Okay, think about log laws as well. Pause video, have a go, see if you can get it right. Okay, if you don't, okay, I mean, see if you pause the video when you're ready and play the video when you're ready. Sorry. Here's the final answer. I don't know how many of you got it right. Let me know. Um, but in the comment section, if you don't know how to start, okay, so as I said, we take ln on both sides to start with. So let's take ln on both sides to start with. Okay. Then we can apply the log laws. So remember, log AB, okay, equals log A plus log B. So we can write log A plus log B. Right hand side remains unchanged. So in here, what have we done? Well, log AB equals to log A plus log B. The difference is we just use ln instead of log. We know ln is just a type of log. It's a natural log. Okay, it's a natural log. Next, what can we do in here? Well, ln 3x. Okay, so ln and e, love it. We can cancel out. Okay, so we can rewrite next step as ln 3 to the power of x plus 4x minus 1 equals ln 5. Now, if I want to make x subject, this is still not helping because x in the power. So think about power, x in the power, and log or ln. Can you think of anything that could connect ln and x? Well, x in the power. Anything about that? The power law. Power law. We can bring the x down. And also add 1 to the right hand side. So ln 5 plus 1. So what have I done in here? Power law. So what's power law again? ln a to the power of k equals k ln a. Right? So my x subject, I can factorize the x. So it becomes ln 3 plus 4 equals, I'm going to rewrite it so I can stop writing bracket 1 plus ln 5. Now I can see in the same as the exam format and the format given to you, ln usually placed at the end of the train of expressions. So I'm going to do the same thing with that one. So it'll be 4 plus ln 3 equals 1 plus ln 5 divided over, that's where you get your answer. Okay, and I believe that's the end of chapter 14.7, where you are going to get used to working out algebra equations with natural logarithms before moving on to modeling with logarithms.